Hello, everybody. So we're going to get started here. This is going to be a deep dive on the pseudo pallet and the utility pallet. So we're going to cover actually two pallets. And the presenters today are myself, Bruno. I'm a support engineer at Parity, and Lana. Lana will be doing the code walkthrough later, and she is an application engineer at Parity. So high level, what we're going to be discussing today is the pallet's purpose, both pallets, pseudo and utility, and some high-level features of these pallets. We're going to discuss a little bit about the extrinsics and how these pallets function, and then we're going to drop into a demo with Polkadot.js. And after that, we'll also open the room for some questions, if there's any questions out there. And then Lana's going to take it off with the code walkthrough. All right. So what is the pseudo pallet, right? If we're thinking from a frame perspective, or even from a higher level, let's start like, what is pseudo, right? Pseudo comes from the Unix world, right? Where in Unix, pseudo is the idea that you can elevate privileges in the Unix system, and you can do something with those elevated privileges, right? You can act as root on the system, or you can impersonate another account. And the word pseudo itself stands for super user do, or sometimes I've heard of switch user, or the other one, I think, switch user. There was another one, I can't remember right now, but ideally it's the idea that you become a super user on the system, right? The highest privileged user on the system. So if we take that concept into blockchain world, this is what we're getting with this pallet, that we're going to elevate ourselves to the highest account, the highest origin in the system. And with that, we can do certain things. All right. So with this pseudo pallet, the way that it works is that you have to designate an account as the pseudo account. We call that the pseudo key. And the way that you do that initially is through the Genesis config. You have to do that right when you're adding the pseudo pallet. You define the Genesis config. You say this is going to be my pseudo key. In development, that's Alice. Okay, and there can only be one pseudo key at a time. You can't have multiple pseudo keys. When you're working with the pseudo pallet, so when you have the pseudo pallet in your construct runtime, along with your other pallets, the typical flow of how to work with a pseudo pallet is that in your other pallets, you have you can have like little helper functions like ensure root. You can see there on the screen it says ensure root, right? So any function, any call that you want to say like this is a special call, it's a privileged call, right? Only the root origin should be able to execute this call. Then you add that ensure root. By adding that, it makes it so that the only way that that privileged function, that call, can be executed is using the pseudo pallet, using pseudo. All right, so that can come in handy for certain functions that maybe you designate in your blockchain that do some pretty powerful things that shouldn't be for everyone. So let's talk about the different calls that are in the pseudo pallet, the different extrinsics that are available to you. The main one is pseudo, right? So pseudo is the one where you use the pseudo key, whoever is the pseudo key, and you say, hey, I want to execute this call as root, right? That's pseudo. The second one that you're going to see in this palette is set key. So for whatever reason, maybe in the development, you don't want Alice, or maybe you start your chain and you start it with a certain pseudo key, and you decide later that you want to switch to another pseudo key. The palette gives you this call called set key where you can execute it. It has to be executed by the pseudo account, and you can switch to designate a new sudo account, a new sudo key. You can also use the sudo pallet to impersonate another account in the system. So you can execute a call as another account. That can be useful at times. You can also use sudo unchecked wait, which allows you to execute a call as root and override the wait. All right, that could be useful when you know that you want to take up perhaps the whole block, right? Maybe an upgrade, a set code or something like that. So let's talk about, like, that's it. Like, there were only 4 extrinsics, 4 calls in the pallet, right? So sudo, you can see there's like a little arrow there, governance, right? So sudo, there's pros and cons, right? Ideally, you want to start, you could start your chain with sudo. Sudo can be quite useful to start your chain, to seed balances, to do certain administrative tasks. So it can be quite useful pallet to just get your chain started. However, as you may have kind of figured it out, sudo is kind of centralized, right? Like, all the power is in one place, right? So it's on one account, and we're building decentralized systems, and we want to go in that direction. So what you'll see is that a lot of chains in the ecosystem, they may start with sudo, but then they will quickly switch to some type of governance. Whereas maybe it's democracy pallet with a few other pallets, collective pallets, and use those origins to execute higher privileged functions. Okay, so that's really important to note. That's like, you can start with sudo, but ideally you want to switch off of sudo. You can actually see there's a PR in Polkadot where we removed the sudo pallet, and we started with sudo and then we removed it in the very, very beginning. So let's talk about the next pallet, which is the utility pallet. Utility pallet, it's a set of functions, dispatchable calls that can be useful for a Frame developer. And it comes in 2 categories. One is in the pseudonymal category, and we're going to discuss that. And the other one is in the batch category. So those are the 2 main categories so far that the pallet has. It's also a stateless pallet, which is interesting. So stateless in this viewpoint here is that there is no storage. Like, in this pallet, we don't need to use any storage. Okay. So let's talk about the first category. In the first one, the idea is that you can have a signed origin, and from the signed origin, you can create an alternative signed origin from that signed origin and execute the call from that alternative signed origin. And the thing is that from the signed origin, you can create multiple alternative accounts. So we're going to show the actual call for this. And this can be really useful for wallets, exchanges, anything that you need to, any type of service where it's like you need to manage a lot of accounts, a lot of keys. This could be useful. So the extrinsic for that is as derivative. As derivative, you can execute this extrinsic and you specify an index. This index is what is going to be used in conjunction with a prefix and the origin that executed as derivative to create this additional account. Index in this case here is U16. And you can see at the top of that slide that the maximum number for U16 is 65,535. So that means you can create that many accounts. So from one origin, and this origin may be assigned, an account. It could be a multi-sig account. From that origin, you can create that many accounts. So that's a lot of alternative accounts that you can create, derived accounts that you can create from one account, right? So it's not limited to only that. You could stack it. So you could go one layer deeper. So from each one of these 65,000 and some accounts, you can create an additional 65,000 some accounts. So I think if you add all of that together, it's like over 4 billion, right? And you can see how powerful this extrinsic can be. And it can be really, really useful when you want like one account to manage multiple accounts. So like I said, like if you have some type of service where maybe you offer some type of like maybe you have a service where you have many accounts that need that the user can deposit into, and you need one account to manage all of those accounts. This can be quite useful. All right, so you can think of like in the ecosystem, like wallets, exchanges, staking providers, anything that the alternative to this you could think of is like you'd need to generate that many key pairs, which that can be really, really hard to maintain, and not the greatest way in terms of security, because each key pair, right, you have a private key. Whereas with this as derivative, you're creating a lot of accounts. You have the option to create a lot of accounts without private keys, right? The derived account is created with a prefix, the index number, and the origin account. So the second category is batching. When you think of it from a frame perspective, it's quite useful to be able to put together a bunch of extrinsics, sign it one time, and dispatch it, right? It's a really useful operation, so much so that we included this in the utility palette. However, there's multiple ways that you could batch. And that's what we're going to show you here. It's the first way is that you can have a vector of calls, and you can call this batch extrinsic, and it will go through each call and execute it. However, if any of those calls in that vector fails, errors out, then it'll fire off a batch interrupted event, and it will end. So let's say if there's 5 calls in that vector and the third one errors out, it's going to stop right there. It won't execute the remaining ones. And it'll also give the index where that errored out. So from that you can say where errored out, which call it errored out on, the error message, and also from that number how many succeeded. So depending on your use case, batch can be useful, where it's like, okay, I want to execute all these extrinsics, but if any of them error out, I want to stop. I don't want to continue. Okay, that's where batch comes in. But sometimes that may not be the use case that you want. That's where batch all comes in. Batch all you can think of as like an all or nothing. So either all these calls inside of this vector execute successfully, or none of them. So it's an atomic operation for all those calls. And if one of them errors out, the whole thing gets rolled back. None of them will be executed. None of them will execute. Okay, depending on the use case, this can be really useful as well. Slightly different than batch, right? There's batch and batch all. The other utilitarian function that exists in the utility palette is dispatch as. So dispatch as is useful if you want to dispatch a call as another origin. So use cases like with Substrate, right? With Frame, one of the features that you get is that you can create custom origins. And you see that throughout Polkadot and Kusama. Like there's collective origins, governance origins. It's up to you as a Frame developer to create your own custom origins. We also come with, Frame also comes with default origins, right? You have signed origin, you have the none origin, you have the root origin. But you can create more, right? So dispatch as can be useful. For example, like if you have governance and you want to execute a call as a parachain, or just in general, if you ever want to execute from governance, perhaps you want to execute as another origin. This can be really useful. One thing with dispatch as, like, I don't know if you remember, but earlier in the slideshow, I discussed about in the pseudo palette about pseudo as, right? What's the difference between pseudo as and dispatch as? So pseudo as also accepts an origin. Pseudo as, you also have to dispatch it from the pseudo key, so as root. However, pseudo as is a specific origin. It's a signed origin. So you're going to say, I'm going to impersonate another account, right? Whereas dispatch as, you're saying, I'm going to impersonate another origin, right? It could be a signed origin. It could be a custom origin. It could be a none origin, right? So subtle difference there. And then there's the last type of batch, extrinsic, which is force batch. And depending on your use case, this one could be the one that you want. So this one, you have a vector of calls, and you're going to go through each call and execute each call regardless if there's an error. It won't interrupt. If the third one errors out, it'll continue to the fourth one, fifth one, and so on. All right, so depending on what you're looking for, this might be the one that you want. It does, however, it will emit an event if there was an error, okay? It just won't interrupt, right? So that's really useful to know. And then the last extrinsic in the utility palette is with wait. With this one, you can override the wait for a call, and the origin has to be root. Okay. So this could be useful. And we saw in the pseudo palette, there was also one pseudo with unchecked wait, right? Just to keep in mind, these are two different palettes, right? So what if in your blockchain you have the utility palette, but you don't have the pseudo palette, right? Then with wait can come in useful, dispatch as can be useful as well, right? So it's quite common, most blockchains, most parachains, they do not have the pseudo palette, right? Because they're already mature, they're already decentralized, right? So, but they will have the utility palette. So they have access to with wait and dispatch as. So let's do the demo, and then after that, we'll open up the room to some questions. All right, so yeah. Oh, I will be doing the demo. Lana is going to be doing the walkthrough, the code walkthrough. She will be in it. Okay, so let's see here. I have a blockchain running. Hopefully you can all see that. And just want to show you a couple things here. Let's take a look at the accounts. So I have some accounts, right? It's a development mode. So you can see, just want to point out that Charlie has a 0 balance, Eve 0, Dave and Ferdy, they're 0, right? So I also have the tab here, one for network, so we can see recent events, and a third one for extrinsics. So let's take a look at pseudo. I'm not going to highlight all the extrinsics. I'm just going to highlight like some of the more well-known ones. So let's start with sudo. So you can see sudo here, right there. And then I'm going to open the drop down here. And let's do the sudo call, right? The most popular one. So we're going to execute an extrinsic via sudo. So yeah, let's do remark. So we're going to execute a remark. Hello, right? You can see, okay, it succeeds. Not a big deal here, right? What if we did something like, I don't know, let's go to balances. Yeah, forced transfer, right? What if I want to use forced transfer, and let's say Bob is going to be the origin here. Bob is going to force transfer some money from Alice to himself, right? And we're going to say 100. This should be an operation that should not be allowed, right? An account on a blockchain should not be able to just transfer from one account to another account, right? That would not create a good system. In fact, it says here, the origin must be root, right? So that means that if I execute this right now, I should get some type of error, perhaps some bad origin. There we go, bad origin. Okay. So this is an example of a privileged function that we discussed, right? Where it's checking the origin has to be root. So that means that this is a great use case to use sudo. So if we go back to our accounts tab, I just want to show you a nice little Polkadot.js feature here. If I click on Alice, the UI is really nice and it shows that Alice is the sudo key, right? That's pretty cool. So if we go back to the extrinsics tab, this one here, and let's use Alice. Alice is the sudo key. And let's use sudo call, and actually do the force transfer. Let's see here. Balances force transfer. And we're going to transfer, let's transfer some amount from Bob. And then this time, let's do it to move some amount to Eve. Remember, Eve has 0 balance. So I'm going to transfer, let's say 800 tokens. And sign it. And we're using sudo, so this should succeed, and it does, right? So if we go to the Explorer tab, we now see the sudo was used, balance transfer from Bob to Eve. And the only reason that worked is because Alice is the sudo key. And there was an amount of 800. So if we go back to the accounts tab, scroll down, Eve now has 100 units. Okay, so sudo is quite useful with privileged functions. We can also use sudo and call, let's say, set key, right? Let's switch the sudo account. So remember that in order to switch the sudo account, the sudo key, it needs to originate from the sudo key itself, right? So Alice. So I'm going to make Bob be the new sudo key. Sign and submit. Okay, looks like it succeeded. Check the Explorer. Key changed. The old sudoer is Alice. Okay, so that's the event that we get. And now if we go back to the accounts, I may need to reload. Let's see. Yeah, see how here it says this? If I reload, it should pick it up. Okay, it's gone. All right, Alice is no longer sudo key. So let's go on Bob. And Bob is the sudo key. All right, so Bob is now the sudo account. That's pretty cool. So let's take a look at the utility palette. Let's see here, utility. And let's look at the batch, right? So batch accepts a vector of calls. So let's create a few calls here. So let's do balances, transfer. So transfer. And we're going to transfer let's say we're going to transfer to Dave, right? Dave has 0. Poor Dave, right? So we're going to transfer 100. Actually, let's do this. Let's say we're going to transfer to 100 to Dave, and we're going to do another extrinsic, balances, transfer. And this time, let's transfer some to Ferdy. Ferdy, I believe, has 0 balance. 100 to Ferdy. Actually, let's do more. Let's give 800 to Ferdy. Okay. And then a third one, just to show you that you can do multiple. Balances, transfer. And we'll give some to Charlie, 100. Okay, so we have 3 extrinsics, and we're using batch, right? So just to show you this, we're going to sign this, submit, and it will execute. All right, so it looks like it succeeded. If we go back to the Explorer, you can see that they all completed because we got an event called batch completed, right? So they all got completed. In fact, if we go back to the accounts tab, we should see that Charlie now has 100, Dave has 100, and Ferdy has 800. So it succeeded, right? What would happen if we slightly change this and make one of these not succeed, right? We're using batch, if you remember what batch does. So let's, for example, let's switch the account here. Instead of taking money out of Alice's account, which has like a whole bunch of money, right? Let's take Eve. Eve has a limited amount. Eve, I believe, has 800, right? If we can check. Eve, 800, okay? So we could give 100 to Dave, okay? That leaves us at 700. Now this one here, it's asking for 800, but Eve will only have 700. So this second extrinsic of index 1 should fail, should error out, right? And then we have the last one that sends 100, which what will happen there, right? Let's see what will happen. So I'm going to execute this. And it looks like we got something going on. Let's look in the Explorer. So there we go. So we got the batch interrupted event, right? And you can see if I collapse this. No, right, yeah, right here. So we get with that, we get the index of the error and the index. This is the pallet index. So in my runtime, in my construct runtime, this is where how do you say, like which pallet is throwing the error. So like I can actually show you this. Let me pull up my screen here. So this is the blockchain that's running, right? And you can see here, we're inside the construct runtime. So these are all the pallets that I have in my blockchain. So if we go back to that browser, it says index 5. So 0 is system, 1, 2, 3, 4, 5. So pallet balances, right? And inside pallet balances, this is where the error occurred. So I can show you that too. So let's see, let me pull up the substrate. So this is the substrate repo. Let's go to pallet balances. So here's the error, right? We're inside of the error enum here. So 0, index 0, 1, 2. Insufficient balance, balance too low to send value. So if we go back to the browser, scroll down, insufficient balance, balance too low to send value. That's the error that we got. Just so you know, right, like how to interpret this, right? And that's where it got interrupted, and this makes sense. And this index here is the index in the vector of calls, right? So it's 1, so that means it's the second call that errored out, which makes sense. It was the one that's going to transfer 800 from Eve to someone else, and Eve at that point only has 700. So the batch got interrupted. That means that any of the calls that were past that did not get executed. So this one here, Charlie sent 100 to Charlie. Charlie already has 100 because we sent him before from Alice, I believe, right? So if this succeeded, Charlie should have 200. And we got a batch interrupted on the second one. So therefore, this one did not get executed. So Charlie should still have 100. And you see there, Charlie only has 100. Okay. So that's batch. Whereas we can also do batch all, right? So batch all is cool. Batch all. And we can say balances, transfer. So I'm going to transfer from, let's do, how much does Eve have? So Eve has 699. All right, so we're going to transfer 100 to Charlie. Let's change the number. We're going to transfer 77 to Charlie. Another transfer. And now we're going to transfer to Dave 800. Right? Because we wanted to intentionally error out just to show you the difference between batch and batch all. And we're also going to transfer at the end here to 30. And we'll keep it at like 77. Okay. So the way that this should work is Charlie right now has 100 in Charlie's account. So we can show that here, 100. We're going to send 77 to Charlie. And then we're going to send 800 to Dave. And we know that Eve only has 699, right? Eve is the one signing and executing, right? So this is going to fail. And because we're using a batch all, what do you think will happen? Let's see. Sign and submit. All right, so we got some type of error there. It's in red. And let's see here. If we go in here, batch all, there's the batch all. And it looks like it failed. Okay, and there it is, insufficient balance. So we got a failure there, we got an error. If we check, right, if we go to the first one, Charlie should get 77, 800, right? We know this is going to error out, but did Charlie get 77? If we go back to the accounts, where's Charlie? Charlie got nothing. Okay, so that's batch all. If one of the calls in that vector of calls fails, none of them get sent through. Okay, so that's important to note between batch and batch all. All right, so that's it for my demo. We'll do the code walkthrough with Lana.
Okay, perfect. So what I have here is I just have the substrate repo here, and in the runtime, we can see the implementations of Pallet Sudo and Pallet Utility. So they don't have a lot going on in them. So essentially in sudo, we only have event and call, and in utility, we also have origin, because like Bruno mentioned, for example, in sudo, we can actually impersonate another account, and in utility and origin, and a lot of weight calculations going on in utility palette, and we will see in a second why. So let's take a look at the code of the sudo palette. And what is worth noticing here, what's interesting. So some things here that we won't see everywhere, such as traits, unfiltered dispatchable. Yeah, so this is when we allow our sudo key, our sudo origin, to dispatch a call without bypassing any filters. Yeah, something that can stop a call from being executed based on the type of account that's trying to execute the call, or any other filters. Yeah, so it's unconditionally dispatchable. What else is interesting in sudo? We see that in the imports we have pub use extension check only sudo account. Yeah, so what this does is this treats all incoming transactions, and as was discussed today by Bruno, this whole sudo palette is in the runtime at the very beginning of the life of the chain, right? So this is necessary as a sort of defense against some DDoS attacks, because essentially an extension is something that checks transactions before they enter the transaction pool, before they can be picked up by somebody and actually executed. Because of course you can check an origin and where a transaction is coming from directly in a call, but that means that the call is already being executed. It's in the mempool. So of course, in the source folder of the sudo palette, in the sudo module, we have the extension file. If somebody's curious, you can look at how it's implemented, and essentially, we see the signed extension implemented for check-only sudo account, and it has certain pre-dispatch validations here. Yeah, so we validate here that the signer, this is the main check here, is that we want the who, the sender of this transaction, to be the sudo key that is set in the Genesis config. So what else is interesting to see here? So call dispatch bypass filter. This is a function that comes from the trait that we mentioned before, the unfiltered dispatch. What is also interesting, that the user doesn't pay a fee here. Yeah, so pays no. So this is the basic, the sudo extrinsic that we have seen before. Sudo unchecked weight. Here we pass the additional parameter to this extrinsic, the weight. Like was mentioned, for example, if we want to fill the whole block. Yeah. What else is here? We can set the key. Has to be of type account ID lookup off, and can be upgraded and put into the storage, and can also be done, of course, only by the old sudo key. The last extrinsic here is the sudo as, and as we see, we can only be another account in this context. So again, we can execute the call without any filters, bypassing all filters, acting as a signed origin of who. Yeah. And the events that are emitted here is, as we saw, key changed, sudo as done, sudo ID. So the difference between the two, of course, they have the same comment, but the first one is when it was executed by the original sudo key, and sudo was done when it was executed as a different account. Requires sudo error. The key, so the storage has only one value here, key. And so this is like the difference, yeah, between the utility and sudo pallet. So that one doesn't have a storage, and this one just has the key. Genesis config can have the key or can not have the key. And yeah, some functions that are implemented for Genesis config. Yeah, so default none, and of course the functionality to build the storage and to put in the key. So this is the sudo palette. This is the extension that is in the same folder, and a few things about the utility palette. So as mentioned, it is stateless. And what is interesting here? So there's quite a lot going on. First of all, there is a batched calls limit. Yeah, so you cannot execute more than you can. Sorry for the for the confusion, but there's a limit on the amount of calls. Error, too many calls. Let's look at what is going on in the weights calculation. Yeah, so we have to, whenever we do one of those extrinsics, yeah, the batch all, or force batch, we of course have to iterate through the dispatch info and actually evaluate how much weight we need for each of those calls and add it all up. And then we actually will add up the weight of this extrinsic itself. Yeah, so the batch extrinsic itself. So let's see what happens. So yeah, here we do the mapping, fold it, and add up all the weights of the from inside the dispatch info of each call. Inside batch, so yeah, what's going on? So we make sure that the origin is not none, and we iterate through the calls, and we have to enumerate them because, like we said, at a certain particular index, yeah, the execution of the batch of calls fails. So we need to keep track of the index, yeah, because if we bump into an error, we return the error, and we deposit the event with the index so that we know where we are. And then the weight calculation happens here. So we have the weight info from batch, from the function that we're in, and then we add it to the base weight. Yeah, so that we know the weight of the whole system. And if we manage to get through the whole cycle here, then we are able to say that the batch has been completed and return the weight of the whole operation. What do we have inside as derivative? So here we set the caller from the pseudonym, where the pseudonym is calculated with the derivative account ID. This function is actually quite interesting to look at as well. So let's take a look at it. It's defined in the implementation of the pallet. So we decode so we pad with zeros the entropy bytes with who and index, and then we decode it to get a standard substrate account. Yeah. So this is what a helper function that's defined here. Essentially, yeah, so we set caller from this pseudonym account. Yeah, so we dispatch the call. But yeah, what's important here, we of course have to pass the index of the sub account of this original account or origin. Let's take a look at the next call, that's batch all. Yeah, so it's a little bit different from the batch one in the sense that the whole operation rolls back if at least one call fails. And another thing that's interesting in here that we see is that we have another filter added here, is that we cannot have inside the batch of calls, we cannot have a call of the same type batch all, so we cannot nest them. So this is an interesting type of an interesting property of this function. Yeah, so it's just interesting to compare how exactly these functions are implemented and how different they are from one another. And here we have the essentially the error is returned if at least one of the calls fails. Yeah, so essentially, yeah. And if everything is successful, batch is completed, and again we have the full weight of all of the calls and the batch all function. Dispatch as, this is the function that's similar to the pseudo, what was it called actually? Pseudo as. So here it's dispatch as, and yeah, so here we pass a different origin from democracy, any kind of other custom origin, and yeah, here we don't have to convert it into origin. We just pass the origin as origin, and again dispatch with bypass filter. And yeah, and another interesting function of the three that execute batches of function is this force batch. And this one, if it bumps into an error, it says, okay, it logs it. So here we have an if let situation, which tells us, okay, so we log item failed with the error that happened, or we log item completed. And then also we track of a Boolean value has error, which tells us that either batch has been completed with errors or without errors. Yeah, so just slight differences in the implementations of the functions. And the last one, similar to the one that we've seen in pseudo, execute with wait. We pass the wait to the utility pallets function and dispatch this as the origin, yeah, the root origin. And yes, and we arrive at the helper function, which we have already discussed. Okay, so this is it from my side. Thank you everyone for your time. Hope you enjoyed the show, the walkthrough and the presentation. And tune in next week for more deep dives about even more interesting topics than utility and pseudo. Bye.